Let me discuss with the design thinking activities. Yes, let me discuss.
Good morning everyone. Today I want to speak about deadlocks and edits. Deadlock is a situation in which a set of processes is blocked because each process is holding another resource and waiting for another resource held by one another. So, for example, if we take process A, it holds resource 1 and waits for resource 2, and process B holds resource 2 and waits for resource 1. So neither process can proceed. This is a deadlock. So this scenario is called deadlock. For conditions of deadlocks are mutual inclusion, hold and wait, no permission, and circular wait. So mutual inclusion is one process can use one resource at a time. Hold and wait is a process holding one resource waiting for others. And no permission is no process cannot be forcibly taken away. Circular wait is a closed chain, it forms a chain where process exists, each waiting for resource hold with another. So this is a deadlock concept. Thank you.
Process scheduling in operating system is a crucial component that manages the allocation of system resources, particularly the CPU, to various processes. Types of process scheduling algorithms. First come, first served. Processes are executed in the order they arrive in the ready queue. Shortest job first. The process with the shortest burst time is executed first. Priority scheduling. Processes are assigned priorities and the highest priority process is executed first. Round robin. Each process is assigned a fixed time slice and the CPU switches between the process. Multi-level feedback queue. Processes are divided into multiple queues based on priority and each queue has its own scheduling algorithms. Goals of process scheduling. Maximize CPU utilization. Keep the CPU busy as much as possible. Minimize turnaround time. Reduce the time taken for a process to complete. Minimize waiting time. Reduce the time a process spends waiting in the ready queue. Minimize response time. Reduce the time taken for a process to respond to user input. Process scheduling techniques. Preemptive solutions. Preemptive scheduling. The OS can interrupt a process and switch to another process. Non-preemptive scheduling. A process runs until it's complete or is blocked. Process scheduling plays a vital role in ensuring efficient system performance, responsiveness, and resource utilization. Thank you.
System case study. A large corporation need to choose an operating system for their employees. Requirements: cost, user experience.
OS are used in variety of computing environments. Traditional computing, mobile computing, distributed computing, client-server computing, peer-to-peer computing, cloud computing, real-time embedded system. Traditional, currently trying to access static memory allocation. It is a single user in OS. Mobile computing refer to smartphones and tablets. Distributed computing, multiple computings work together to solve computing problems. LAN, WAN, MAN, PAN. LAN connected to within a room, building campus. WAN, city or countries. MAN within city and Bluetooth. Client requires a resource, serve and provide that resource. Peer-to-peer computing. First join network and number of nodes are directly connected to the network. Cloud computing. All the data is stored in cloud computing.
This is a situation when a set of processes are blocked because each process holding a resources and waiting for the another resources by another process. There are the code conditional, mutual exclusion, hold and wait, no permission and circular wait. System model. System model is the collection of limited resources and then divided into the different categories. Memory, print, CPU, open file and CRO is the resources category. For example, the term printer may need to the subdivided, laser printer and color inkjet printer. Some categories only have one resources. Operation request cannot be granted immediately.